Stationary point. Differentiation. Example 8. A. Show that the graph of y equals x to the power 4 plus 8 over root of x, where x is greater than 0, dy dx equal to 0, when x equal to 1. B. Sketch the graph of y equals x to the power 4 plus 8 over root of x, where x is greater than 0, labeling the coordinates of the stationary point. If we have a graph of y equals x to the power of n, then dy dx equals n x to the power n minus 1, d2y dx squared equals n into bracket n minus 1 x to the power n minus 2. So we have to make sure the function we have is in this format. We have y equals x to the power 4 plus 8 over root of x. And that can be written as y equals x to the power 4 plus 8 times 1 over root of x. Root of x equals x to the power a half. 1 over root of x equals x to the power minus a half. So therefore, y equals x to the power 4 plus 8 x to the power minus a half. We've got a function in that format now, so now we can apply dy dx. dy dx will be equal to 4 times 1, that's 4, x to the power 4 minus 1, 3, minus a half times 8 is minus 4, x to the power minus 3 over 2. Minus a half minus 1 is minus 3 over 2. But we need to show that dy dx equal to 0 when x is 1. So dy dx when x equals to 1 will be equal to 4 1 cube minus 4 1 to the power minus 3 over 2. 1 to the power 3 is 1. 1 to the power minus 3 over 2 is 1. Therefore, 4 minus 4 equal to 0. So dy dx when x equals to 1 equal to 0. So that's what we meant to prove. B, we need to sketch the graph of y equals x to the power 4 plus 8 over root of x when x is greater than 0. We need to label the coordinates of the stationary point. At the stationary point, dy dx equal to 0. So we know that at stationary point, dy dx equal to 0. So when x equal to 1, y will be equal to, if you put 1 here, that will be 1 to the power 4 is 1, plus 8 over 1, because root of 1 is 1. So y will be equal to 9. 1 plus 8. So from the function y equals x to the power 4 plus 8 over root of x, as you increase the value of x, the value of y gets larger. We know that at the turning point, the y dx is 0, and it has a coordinate at that point, x equals to 1, y equal to 9. So that's the coordinate of dy dx at the turning point. X equals to 1, y equal to 9. So the coordinate is 1 and 9. So at the turning point, this is a turning point here. This is where the y dx is 0. If the 2y dx squared is positive, so the red one here is the y dx equal to 0. And here is the 2y dx squared. And if that's positive, that means greater than 0, then the curve is a minimum. That means I'm going from 0, turning point here, to positive. So that's a minimum. That's what the 2y dx squared is telling us. But if the 2y dx squared is not positive but negative, then the curve here will be maximum. So that will be max, and that will be min. So that will be the 2y dx squared less than 0. So that's what we're trying to prove here at that point, the turning point. So at the turning point, the coordinates are 1 and 9. So now we need to find the 2y dx squared. The 2y dx squared will be equal to, if we differentiate that again, 3 times 4, 12x squared, 3 minus 1 is 2, minus 3 over 2 times minus 4 will be plus 6 x to power minus 3 over 2 minus 1 is minus 5 over 2. And that will be equal to 12x squared plus 6 over, we could say, x to power 5 into bracket to power minus a half. And we know what that is. That would be 1 over x to power 5 to power a half. We know what x to power a half is, root of x. So that would be root of x to power 5. But when x is 1, so we need to find the 2y dx squared when x is 1. So when x is 1, the 2y dx squared is 12 1 squared plus 6 over root of 1 to power 5. And that will be 12 plus 6, and that's 18. That's positive. The 2y dx squared is positive, greater than 0. So it's a minimum. It is a minimum. But now we need to sketch the curve. So to sketch the curve, we know that x equals 1 here, and y equals 9. So that's the point here, the minimum point. So this is y, that's x. And the curve has a minimum turning point here. But as x increases, the value of y increases. Because the smaller value you get here, the larger value you get overall. So that goes up. You cannot have x equal to 0. Because if x equal to 0, that would be 0 there. And that would be 8 over 0. It's undefined. So this curve will just approach 0, x equal to 0. So the coordinate here will be 1 and 9. And that's the curve. So you could try some values, positive values along here. When x is 0.5, you get a higher value. When x is 2, you get positive values along here. So you could plug in some values to just test the values along here. Remember, the graph has to be x greater than 0. So we have to plot the graph from along this to the right hand side of 0, because we want x greater than 0 along there. And that's what we get. And you can see that's a minimum.